Okay, here we've got a question from the June 2010 paper, and clearly it's a velocity time graph. So it tells us in words what's happening. We've got a bus slowing down, stopping, then accelerating away. But that's kind of what we can see from this anyway. We've got to state the length of the time for which the bus is at rest. Okay, well that's this period here when the velocity is 0. So that's 70 minus 40, which is 30 seconds. Okay, find the distance travelled by the bus in the first 40 seconds. So this is a velocity time graph. So the area under the graph tells me displacement. Okay, this is all positive area, so displacement and distance are effectively the same thing. So I have to find the area. So I'm going to have to do a half times the base, which is 40, times the height of the triangle, which is 20, which is 400 meters. Find the total distance travelled in the 120 second period. Well, I've got another triangle with a base of 50, 70 to 120. It's also got a height of 20. So a half times 50 times 20 gives me 500 meters. So we've got to do 500 meters for that one, plus the 400 meters from before. Don't really want units on that. So that's 900 meters. And then we've got to say if it had not stopped but travelled at a constant 20 meters per second for all 120 seconds, how much further would it have travelled? So if I'd been going at 20 meters per second for 120 seconds, I don't even need to visualise that as an area. That's just 20 meters per second times 120 seconds is 2,400 meters. And the question is how much further. So it did go 900 meters. This is how far it would have gone. So the further distance is going to be the difference between those two things. 2,400 minus 900, which is 1,500 meters. 1.5 kilometers if you like, but that's absolutely fine. Now, this is not how to set it out. Obviously, you'd write all your answers in the lined answer space. I've just been doing it like that because this is a very easy question, and because you can see the question and my answers at once. But okay, wasn't that fun?